Welcome to the session on linear programming simulation. In this one, we'll discuss about linear programming simulation using Excel solver, as well as we'll see how to solve linear programming using the Tora software. Writing over here 2x1 plus 2x2 equal to 20. First I am assuming x1 equal, when x1 equal to 0, then x2 equal to 20, that means x2 equal to 10. Similarly, I am making x2 equal to 0, then x1 becomes 10, and these values I have put over here: 0, 10, okay, and 10, 0. So this is for my first equation, and similarly this is for the second equation, that is 2x1 plus 4x2 is less than equal to 24. So for that one I have calculated this way, x1 and x2, and just like this way. Okay, so we'll solve this one. We are going to draw the graph for this. You select the first equation, 4 numbers, go to the insert, and in the graph you select the scatter graph, second one. Okay, and then after putting over here, then you just write over here, select data, add series name, you can write series 2 or constant 2, whatever, and x values I can select. Similarly, y value, that is my x2 values, I can select from here. Then I'll put this one. Okay, in this way the feasible regions are this particular thing. So I can insert over here, this is my feasible region. Shape outline I will also give black color as the, and then after I'll copy this one, paste. So I'll use the objective function, and based upon that one I'll put the formula over here. What is the formula? That is 6 multiplied with, that is 6x1, so this value, plus 8 multiplied with x2 value, I'll put over here. Okay, and then I'll just drag this one for 3 values. So this is my first point, point 1, or feasible point 1. So feasible point 1, how much is my x? X is 0 and x2 is 6. Over here it is, you can see over here, it is 8 is the x1 and 2 is the x2. Similarly in the third point it is 10 is the my x1 and 0 is my x2. So on that basis I'll say that my point 2 is the optimized value. Okay, that is this point. Now on that basis I can say my x1 is 8, x2 is 2, and z is 64. Okay, so this is all about the graphical method. How to solve this one using the simplex method. So in the simplest method, I do not know. I have to find out what is my x1. X1 is my variable 1, x2 is variable 2, z is my objective function, and this is my constant 1, constant 2. And I have defined this one. This is variable 1. You can see over here it is variable 1. Okay, this is my variable 2. This is my objective function, and this is my constant 1. This is my constant 2. Okay, x1 I do not know the values, x2 I do not know, so objective function I'll write over here equal to 6 multiplied with x1, that is my variable 1, plus 8 multiplied with my variable 2. Okay, constant 1 says that it is equal to 2 multiplied with x1 plus 2 multiplied with variable 2, that is my x2. Here also I'll put the formula, that is equal to 2 multiplied with my variable 1 plus 4 multiplied with my variable 2. Okay, after writing this one, I'll keep the cursor over here, and then I'll go to the data, and then I'll click over solver, and set objective would be my, this is my objective function. Okay, by changing variable cells are my variable 1 and variable 2, which is already been defined. Then I'll add constants over here. What is the constant? This one is less than 20, as well as second one is that this one is less than, I can use any symbol over here. Okay, so this is 24 odd, and then after I'll also use x1 is greater than equal to 0. Similarly, I'll also write my variable 2 is also greater than equal to 0. I'll add over here, then I'll press OK. Why? Okay, it has already been done. Then there are select solving method, different methods are there. I'll select the simplest linear programming. Okay, and then I'll click solve for this one. Okay, now I'll select all this one, answer, sensitivity, and limit, all this I'll select. Okay, then I'll click over here OK. Now you can see we are getting the result over here 8, 2 and 64. 8 is my for x1, you can find for x1 it is 8 over here, x2 equal to 2. Just like that we have also found out the values. Okay, beyond that we have also find here also 6 and 8 is there. Allowable increases 2, allowable decreases 2, allowable increases 4, and this is 2. Okay, so this is the sensitivity report. We will go to our another software, that is the Tora. I'll click here, and then I'll go to linear programming, go to input screen. This is my number of variable for the same problem, that is 2. Number of constant is also 2. Okay, then I'll press tab over here. Okay, variable name is my x1, variable 2 is x2 plus 8x2, constant 1 is 2x1 plus 2x2 is less than equal to 20. Similarly over here 2x1 plus 4x2 is less than equal to 24. Okay, then I'll press solve menu. I do not want to save the data. Okay, solve problem. First we'll see in the graphical one. Go to output screen. We have to click over here and you can see this is the optimum value it is showing over here. Okay, now we'll this one, then again I'll go for the solve menu. No, solve problem using the algebraic output screen. You can see here, if you remember in the simplex method we have this problem z equal to 6x1 plus 8x2 and the constants were given, and final table we got this way: z equal to this much, z x1 x2 x3 and x4. These are x3 and x4 are my x3 is slack variable, used for x1 variable, and x4 is the slack variable used for x2. So this slack variable, they are going to give us some interesting result. 3 value for x2 is 2 divided by minus 1 by 2, that equal to minus 4, and 1 divided by 1 by 2 equal to plus 2. So this minus coefficient, wherever this minus coefficient are there, that is for the my x1, that becomes the upper limit, that is 6 plus 2 equal to, it becomes 8 over here, and the plus coefficient like over here, this one would be deducted from here and it will give me the lower limit of 4. Similarly over here for my x2 minus 1 by 2 plus 1 by 2, so 2 divided by, that is the objective function row, divided by minus 1 by 2 gives rise to minus 4. So I'll add over here, that becomes my 12, and this 1 divided by 1 by 2, that will be 2. So I'll be deducting this 2 to determine the lower limit, that is my 6. So I have two conditions. First, I have kept this C1 constant. C1 is nothing but this coefficient, and C2 is my coefficient 2. So 6 is being fixed over here and C2 value has to change. Okay, so 6, how much is the lower value that we find out for the C1 and C2, that is over here. For this one it is over here. Okay, so lower limit will start from 6 and upper limit will go up to 12. So it would be 6, 7, 8, 9, 10, 11, 12, then 13. 2 is nothing but that is the this one. So here this one I can find out the difference over here, the will not be there. Here it would be 2, this one would be 2. Everywhere we'll find this 2 difference, okay, till this point. Okay, so this one becomes 64 minus 2, that is 62. This one would be 60, this one would be 66, 68, 70. Okay, but after this upper limit, what will happen is that if you will calculate using the Excel server or Torah, you will find out the difference will not be 6, it will not be 2, it will become 6. You can try out that one. Okay, similarly over here, that is for when we are keeping the C2 constant. C2 is my this one, for this x2, this one I am making it, keeping it constant. Okay, then when I am keeping the this one constant, then this value would be changing from which number to which number, from that is from 4 to 8. So I'll write over here 4, 5, 6, 7 and 8, and difference over here it would be 8, that is my this one. Okay, here also it would be 8, and here also this one would be 8. After this it will not follow this norms over here. So this one would be 64 minus 8, that is 56. This one would be 48, and this is be 72. This one would be 80. Okay, so if you know this equation and this problem, we can easily find out how much would be the lower limit for x1 and how much would be the upper limit, that is by x2, and lower limit and the upper limit, and I can find out this one values, that is the 20 and 24. Can you make any changes over here? That we'll also see now. Here this one would be divided just like in the previous one. This one would be divided by 8 divided by 1 and 2 divided by minus 1 by 2. So this becomes 8 and another one is minus 4. Okay, so 8, it is a positive one, so we'll deduct from this one, it becomes 12, and this one would be similarly for the second one, that is 8 divided by minus 1 by 2, that would be minus 16, and 2 divided by 1 by 2, that would be 4. So 24 minus 4 equal to 20 would be the lower limit, and 24 plus 16, that would be 40 would be the upper limit. 23, 24, 25, 33, 34, 35. So difference over here is this slug variable. So I'll write from here, this one would be blank 1 1 1. Would be of this one. So you can check this
Thank
one
you
with the
for
Excel
watching
server
this video.
as well as Torah.